Okay, so good afternoon to all of you. So am I audible, online students? Okay. So from today we are beginning with the science and tech module part. So we have divided the classes in two sections, two broad sections. Firstly, we'll be covering the technology portion, and we will not only focus on technology, but we'll also focus on the basic science aspects also, which often UPSC asks in prelims and even in mains. And then we'll cover the biology and biotechnology portion. So some of you would be from science background, but I think some of you would be from arts and commerce background also. How many of you are from arts background, arts and commerce? Mostly arts and commerce background online also. So most of you would be from arts and commerce background. Yeah. Even science background students, I think you would have forgotten science, no, because you would have studied back in school or in college, and now you have to again study it in the UPSC. For arts and commerce students, it always becomes a little a difficult thing to pick up initially, because you would have not studied that well in college, or college you haven't studied it at all, and in school you would not have developed an interest in that. So UPSC has kept this in the syllabus. In which paper is it mentioned? In GS paper? It is mentioned in GS paper 3. Yeah, come. So what is the importance of science and technology? Which note do we generally use here? Note 5 or note 3? तो चलो note 5 ही करके देख लेते हैं. So science and technology, we would see some important keywords mentioned in your syllabus. These you can think of as important broad themes also that we have to cover. One of the most important theme is space science and technology portion. Then comes nuclear science and technology portion. Now, energy technology, this UPSC has not mentioned exclusively in the syllabus, but from past few years, particularly past 2 3 years, we are seeing a lot of questions are being asked from or from alternative energy sources. So nuclear can also be used for energy, but there are other alternative energy sources which UPSC is asking. So we'll cover this also. Then we would cover defense technology. Then there are smaller topics like IPR, nanotechnology. Then IT and computers. Biotech I'm mentioning here, but we'll cover that a little later, and it would be a big section in itself. So this we would be dealing later. So in these first few classes, or around 15 16 classes, we'll try to cover these important topics. So space is a very important area, and a lot of development is going on, so you should be aware about this. There are other topics also which are important. Now let me ask you a general question, like what is science and what is technology? Why we use two terms? Why not one term for it? Is there a difference between the two terms? What is science and then what is technology? Why not one word, just science? What is science? पॉल साइंस वाले भी लोग पॉलिटिकल साइंस को भी साइंस बोलते हैं, सोशियोलॉजी वाले भी बोलते हैं ये सोशियोलॉजिकल साइंस है, एंथ्रोपोलॉजी वाले भी बोलते हैं वी आर साइंस. सो व्हाट इज साइंस एक्चुअली? थ्योरी विच वुड बी एन आउटकम ऑफ एक्सपेरिमेंट. बट आइंस्टीन ने तो बहुत सारे थ्योरीज दी हैं, उन्होंने कभी कोई एक्सपेरिमेंट करा ही नहीं अपने जीवन में. You are correct in saying that it would be about giving theories. What is then science in general? Experimentation can become a part of science, or it is a way of understanding things. Science is basically what? Science is about knowing the rules of nature, knowing the laws of the universe, uncovering the laws of the universe. So we are into a universe and we are governed by those natural laws. In polity, you have studied about human made laws, but nature itself has its own laws. And do we need to know those laws also? How do we know those laws? How can we come to know about those laws? We can come to know about those laws when someone would think about it. So when they think about it, when they then they would give theories about it. How can they think about it? जैसे आपने एग्जाम्पल सुने कि बचपन में कि न्यूटन ने एप्पल गिरते हुए देखा, तो उन्होंने क्या देखा, मतलब ही इज डूइंग एन ऑब्जर्वेशन. Based on observation, he'll give a theory, and then that theory has to be proven. So to prove his theory, he'll come out with mathematics or come out with mathematical models to prove it. Then we'll conduct more experiments. So by doing these things, we are able to uncover the laws of the universe. For example, gravity. So now we know a lot about gravity. By how? By observing, by doing experimentation, by giving lots of theories, and then researching more and more on it. So science is basically uncovering the laws of the nature by different ways, by theorizing, by experimentation, by observation. So these are multiple ways of knowing the laws of the universe. Technology would be utilization of this knowledge that we acquire. So we observe space, we observe our universe, we observe our natural phenomena, and then based on that, when we start developing products, processes, then that would be called as technology. For example, you would have heard about Newton's third law of motion. सुना है न्यूटन थर्ड लॉ ऑफ मोशन के बारे में? Every action has equal and opposite reaction. So for example, when you're walking, you are trying to push earth behind, but your mass is very less compared to that of earth. So earth instead is pushing you ahead. So this is Newton's third law of motion. So this you can observe in so many areas. Can we utilize this to make rockets? We are utilizing it to make rockets. So जैसे PSLV, GSLV आप देखते हो उसमें क्या कर रहे हैं? गैसेस को नीचे थ्रो कर रहे हैं, तो रॉकेट फिर ऊपर की तरफ जा रहा है. So using the knowledge of science, we are building technology, we are building products and processes. Are you getting the idea? So this is the broad idea of science and technology. See, UPSC is not going to ask you difference between science and technology, but UPSC is going to ask you these specific technologies also, or specific concepts also. Now, let's understand the importance of science and technology from prelims perspective and even from mains perspective. So in prelims, you all are now aware that there are 100 questions. So how many questions do come from history, polity, geography, economics, then science and technology? I'm just looking for rough ballpark number. हिस्ट्री से कितने सवाल आते होंगे 100 में से? हाँ चलो 10 लास्ट ईयर या 2 साल से कम हो सकता है, बट रफली वी कैन से इट वुड बी इन द रेंज ऑफ 15 क्वेश्चन. पॉलिटी हाँ 15 to 20, and geography similar 15 to 20 questions. Economy also roughly around same. The number could vary in the exact year, but roughly we are saying around 15 questions. Science and technology कितने सवाल आते हैं? 4, 5, more than 10, less than 10? Yes. So the weightage of science and technology is increasing nowadays in UPSC prelims exam. Roughly, we can say that there are about 15 questions which are being asked in your prelims paper. But in UPSC syllabus, nowhere they have mentioned that they would be asking 15 questions from science and technology. In fact, for none of the portions, they would be mentioning that how many questions they would be asking. But by analyzing the PYQs, we know the weightage of science and technology is not less. Can you see the weightage is no less than some of the bigger subjects that we study for UPSC? And these are called as the core subjects for UPSC. You have to be good at this. In fact, you have to be very, very good at the core subjects. But you cannot ignore smaller subjects like science and technology. You are thinking it is a smaller portion, but UPSC is not thinking from that perspective. UPSC is asking a lot of questions from science and technology perspective. So you have to be good at this portion in order to excel prelims at least. Any of you giving a forest services exam also, preparing for forest services? फॉरेस्ट सर्विसेज का कट ऑफ कितना जाता है, या लास्ट ईयर का कट ऑफ आपको पता है, या एस्टिमेट कुछ पता है? So let's say this side we have total number of students, and this side we have marks. This is the famous bell curve which is true for most things in our life. ये जो कट ऑफ है वो लास्ट ईयर कितने पे गया होगा प्रीलिम्स का? सो वी आर टॉकिंग अबाउट प्रीलिम्स. Any idea? Roughly, let's take this as 90 marks. Last year इससे भी कम था, 70s में था. Then this year probably it is higher. So all those students, those who are on this side, they have passed the prelims. They would be writing the mains. And for forest, the cutoff would be roughly around 105. So you have to score quite high to clear the forest prelims itself. Now, generally, if you see from prelims specifically, there are 100 questions. If you have filled a bubble and you have got it wrong, so you filled a bubble, it means you attempted that question and you got it wrong. How much marks are you losing then? One question is of 2 marks and there is a penalty of 1/3. So you would lose 0.67 marks if you get a question wrong. So have you potentially lost the 2 marks that you could have got had it been right? And you are also getting penalized also. It means one question that you attempt, and if you have not got it right, it means you will be losing potentially 2.67 marks. And the peak of this curve you will not see is very far behind. It would hardly be 10 to 15 marks behind. Peak means most of the students are in this zone. So if you are a sincere student, if you are studying well, then also there would be high probability that you could be falling in this range and not in this range. If you want to be sure that you are in this range on this side of the curve, you should not ignore smaller subjects like science and technology, because all of you would be studying these core subjects quite well, and then difference would arise in these smaller sections like science and technology, environment, and current affairs. You have to be good at this, but you cannot ignore this. uh, Generally, what is the myth or perception with respect to science and technology? If I cover my current affairs, if I read newspaper, if I read magazines, then my science and technology can be taken care of. But you will see, we will see the questions also, PYQs. You will see sometimes they're asking very basic questions involving concepts itself. So you have to invest some time and energy to build your concepts in this portion. If you do not put or invest time and energy for building concepts, it might happen that you attempt these questions. For example, a student who is thinking that this is just current affairs, so he would attempt, let's say, 14 questions, but his accuracy would not be very high. So he could be getting 7 questions right. But if someone who has prepared or given time and energy to build the concepts, he or she would also be attempting 14 questions, but the accuracy could be much higher, let's say around 12 questions. Can you tell the difference between the marks of the two candidates in this case? 5 more questions correct for this candidate, 5 more correct bubbles. One right bubble would fetch you 2.67 marks. So can you realize it would boil down to 12, 13 marks? So if you are here, you would be easily crossing the cutoff. If you are here, you can be very sure that you are clearing your prelims, and there is a possibility that you can clear even the forest services also. So that is why one point that you should remember in UPSC exam, it is a competitive exam. Yeah, so the first stage is an elimination stage. So they are trying to check out those students, those who will ignore some parts. So you cannot skip any part. So science and technology is conveniently ignored by most of the students. So this at least you should know, that you should not be ignoring it. This is the one of the most important aspects that you have to cover for your exam. So there is a relevancy for this particular topic that you have to cover in prelims. In mains, the weightage is less. Yes, I would agree. Around 3 to 4 questions are being asked in GS paper, but again sometimes the questions can appear in GS paper 1 also, science and tech question in paper 1 and even in paper 3. So roughly around 40 to 50 marks question would come in mains. So weightage in mains is relatively less, but you will be writing mains only if you are clearing prelims. So prelims is a difficult stage for most of the students, so you should focus on this part itself. So this is from exam perspective. Now, can you think of the reason why UPSC is giving so much weightage to science and technology? Why are students and commerce students are being asked to study science and technology again? जो गलियां उन्होंने छोड़ दी थी फिर से वापस क्यों आने के लिए बोल रहे हैं? क्यों पढ़ना है आपको साइंस एंड टेक्नोलॉजी? Governance is evolving, so you need to be aware about latest technology itself. Yes. Do you think India can become a developed country by not focusing on technology and innovation? Why USA is considered to be the most developed country? Or you will always hear with respect to USA that it is a technology led country. In fact, you will see some companies like Nvidia, Apple. Nvidia का नाम सुन रहे हो आप लोग आजकल? Chip maker, Apple. Their net worth is more than $4 trillion. इंडिया की जीडीपी अभी इतनी है, ये एक कंपनी 4 ट्रिलियन पे है, एप्पल भी 4 ट्रिलियन पे। आप मैग्निफिसेंट सेवन का नाम सुन रहे हो यूएस में, दीज आर 7 बिग कंपनीज ऑफ यूएसए। इफ यू कंबाइन then it is multiple times, their net worth is multiple times more than that of GDP of India. Why that is the case? वो किस चीज़ पे फोकस कर रहे हैं? टेक्नोलॉजी पे फोकस कर रहे हैं, and that is why you would see the best of the talent of the country is also moving outside only. So you experience what? Brain drain. Why are you experiencing brain drain? Because India is not creating such kind of ecosystem where we can keep such talented people. So you would be a policy maker in future. So if you are going to be a policy maker in future, then you have to determine the policies in which you have to encourage development of technology, development of science in the country itself. You have to bring change in governance also. सो गवर्नेंस पे आपने सुना होगा, ब्यूरोक्रेटिक गवर्नेंस है, रेड टेपिज्म है, लोग चेंज नहीं होना चाहते, स्टेटस क्वेस्ट होते हैं, फाइलिंग सिस्टम पुराने सिस्टम पे चल रहा है, तो आपको वो चेंज करना है तो नई सिस्टम आपको लेके आना पड़ेगा. डोंट यू थिंक यू योरसेल्फ शुड बी अवेयर अबाउट न्यू डेवलपमेंट्स? If you do not, if you're not aware about blockchain, how do you think you can change the filing system in the government? You should be aware about blockchain. That blockchain can be applied in filing system, in elections also. So we should be aware. Now, you could be asked that India is a global space power. It is emerging global space power. What can we do to make it more powerful? The share of India in global space economy is still very, very low, around 2% only. So you should know basic space science also. You should know the policy perspectives also. Then only you can bring changes in the system. So if you want to bring changes in the system, you should be aware about the latest development also. और क्या ये आपके टेम्परामेंट को भी चेक करता है? क्या आपके एटीट्यूड को चेक करेगा ये? Generally, the way we have been taught in school and colleges, we have started identifying ourselves with a particular stream of knowledge. जैसे आप बोल रहे हो कि मैं आर्ट स्टूडेंट हूँ, या मैं कॉमर्स स्टूडेंट हूँ, या मैं साइंस स्टूडेंट हूँ. आप डिस्ट्रिक्ट में आप डीएम हो, और आप डीएम हो और तब वायरस का न्यूज़ आता है. लेट्स से दिस इज ईयर ऑफ 2020 एंड देयर इज अ न्यूज़ दैट अ वायरस इज कमिंग. कैन यू से टू योर लीडर्स that I will not read or I'll not know about viruses and bacteria? मुझे क्या पता ऑक्सीजन कहाँ बनता है? I have not studied anywhere. Can you say like that? No. Why? Because you are leader. So since you are leader, it is expected from you that you will learn new things also. So you cannot say that I'm an art student or a commerce student, I'll not learn new things. So it is checking the basic attitude of yours also, that whether you are open to learn new things or not. So you have to focus on these aspects. So that is why they have kept it in syllabus itself. What we'll do, let's begin with this portion, space science and technology. So the first topic that we'll be covering, Acha, before we start covering, you would be reading newspapers, you would be reading magazines, you would be exploring things online. Also, you're using generative AI, ChatGPT, so many AI tools you're studying. Can you give some recent news with respect to space? Anything that has come in news recently in space? शुभांशु शुक्ला जी का नाम सुना होगा. So Shubhanshu Shukla went to space. So when you see this in news, so he became the second Indian in space. Now यूपीएससी आपसे क्या सवाल पूछेगी कि शुभांशु शुक्ला जी कौन से सिटी के हैं, कौन से डिस्ट्रिक्ट के हैं, कहाँ से पढ़ाई करी है, क्या ये इस टाइप का इंफॉर्मेशन पूछेंगे आपसे यूपीएससी? व्हाट विल यूपीएससी आस्क? हैज ही बीन सेंट using Indian launch vehicles? No, he was sent by using American launch vehicles. It means we have not been able to send human missions. And NASA, way back in 1969, they have conducted human landing also. Neil Armstrong, Buzz Aldrin landed on moon itself. So what has ISRO not been able to do? ISRO has been able to send some missions, but ISRO has not been able to conduct human missions. So UPSC will ask you, or it would expect from you, that you are aware about what is human mission, because this is an example of human mission, but it was not an Indian human mission. We want to have our own human mission. So from UPSC perspective, you should know what are challenges in sending human mission. Why has ISRO not been able to send human missions till now? What are benefits of sending human mission? So if you are prepared from that perspective, the news item like this, that Shubhanshu Shukla ji went to space, it would be just what? One news. It should not be new for you. It should be that I am already prepared for human mission. I already know what are challenges of human mission. I already know benefits of human mission. I already know previous examples of human missions. And this is another news for me. So UPSC would ask you challenges and benefits of human mission. Are you able to understand the idea? So news can become more relevant to you only if you are well versed with the basics. Another, let's take another example, defense tech. S-400 का नाम सुना है आप लोगों ने? एयर डिफेंस सिस्टम, ईरान, अभी इंडिया पाकिस्तान जो ब्रीफ कॉन्फ्लिक्ट हुई थी उसमें S-400 यूज हुआ था. Where have we got this from? We have bought it from Russia. And now, what type of question do you expect would a UPSC ask? This is in news this year, but UPSC in 2021 has already asked a question on S-400 in mains. तो किस टाइप का सवाल पूछा होगा उन्होंने? उन्होंने पूछा है that why it is considered to be one of the best missile defense system, why it is considered to be one of the best air defense system. ये न्यूज़ में अभी इसलिए है क्योंकि ये अभी it was seen in action, but India was in negotiation. India has been trying to buy it from very long, so it was in news for a long period of time. So it should become a part of your preparation only, that what is S-400. So S-400 is one missile defense system. Are we having other missile defense system? आपने आयरन डूम का भी नाम सुना होगा, तो आपको ये भी पता होना चाहिए कि आयरन डूम और S-400 में क्या डिफरेंस है, क्या सिमिलैरिटी है. सो कुछ टेक्निकल एस्पेक्ट्स पता होने चाहिए. बहुत ज़्यादा टेक्निकलिटी की ज़रूरत नहीं है, बट कम से कम ब्रीफ कंपैरिजन तो आपको पता होना चाहिए. सो अगेन, the S-400 should not become a news, entirely new thing for you. Yes, it is in news, but you should have already prepared missile defense system. So it should not surprise you. Nowadays, are you hearing about small modular reactors? SMRs के नाम सुन रहे हो आप लोग? SMRs, small modular reactors. So if you understand what is a fission reactor, if you understand how a nuclear power plant works, what are challenges in existing nuclear power plants, तभी आप समझ पाओगे कि सरकार या गवर्नमेंट इतना फोकस क्यों कर रही है कि SMR हमें लेके आना चाहिए, small modular reactor. Then only you will be able to appreciate the properties of SMR, because there are challenges in building large nuclear power plants. So if you understand the context, if you understand the basic science, then you can appreciate something in news also. Coming to IT and computers, is ChatGPT a lot in news? We are using this product time and again on daily basis. ChatGPT आप use कर रहे हो. तो चैट जीपीटी पे क्या सवाल पूछेगी यूपीएससी आपसे? व्हाट काइंड ऑफ क्वेश्चंस डू यू एक्सपेक्ट? Chat GPT is part of what? It is a part of a broader revolution which is going on, which is artificial intelligence. It is one application of AI. So it would ask you in general what are different application areas of AI. So it can ask application of AI in agriculture, in health, in education, in different sectors. One area is chat GPT. It is called as natural language processing. नेचुरल लैंग्वेज प्रोसेसिंग का क्या मतलब होता है? हम और आप जो लैंग्वेज यूज़ करते हैं उसको बोलते हैं नेचुरल लैंग्वेज. कंप्यूटर्स नेचुरल लैंग्वेज नहीं समझ सकते, वो उनका लैंग्वेज क्या है? जीरोज और वन का लैंग्वेज है. सो दे कन्वर्ट आर नेचुरल लैंग्वेज इनटू लैंग्वेज ऑफ जीरोज एंड वन और मशीन लैंग्वेज. Then they do the processing. So this is just one application of chat or NLP, natural language processing. Then UPSC would ask you, what are ethical challenges in using AI? क्या AI के ethical challenges हैं? क्या social political challenges भी हैं AI को use करने के? तो आपसे ये expected है कि आप उसके policy level वाले issues को समझो. Getting the idea? Broad idea. Also, one common theme you will see in UPSC mains is we are intending to send humans on moon. हम इंडियंस को मून पे भेजना चाहते हैं, पर आपसे ये सवाल पूछा जाएगा कि इसरो जो भी काम कर रहा है उससे हमारे सोसाइटी को क्या बेनिफिट हो रहा है? What is the benefit to socio-economic development, or is it helping in socio-economic development? So will it be beneficial to send humans on moon or Indians on moon before, or we are already suffering from poverty and many other social ills? So first we should fight poverty, or first we should be sending humans? Those type of theme-based questions also becomes important in science and technology. So we'll try to deal with those type of questions also. What should we be doing? Okay, we'll try to deal with those type of questions. So let's begin with this part, space. In space science and technology, there are some important concepts. So I'm just listing down the first, the table of contents or some of the important topics that we'll be covering here. So we would begin from the very basics. We'll try to understand what do you mean by Big Bang theory, what is the relevance of this theory, then composition of universe, what is the universe made up of. These are basic sciences, but questions are being asked, so that is why we should be aware. Then we'll look at our galaxy, which is the Milky Way galaxy, some aspects of it. Then we'll try to understand our solar system. This is quite important from exam. So solar system, you should know about sun itself, some properties of sun, some concepts involved in sun. So what is powering sun, you should know. So we'll understand what is fusion, what is the process of fusion process. You will come across terms like solar storms or solar cycles. So all these terms we'll try to understand. Even birth of a sun or birth of a star, that also will try to study birth and death of a star. So UPSC has been asking questions on birth and death of a star also. So we should be aware about how our star was born, what will happen to our sun if it dies. So those are some basic concepts that you should be aware of. Then we would also try to understand what are planets, some basic aspects. What are planets, what are asteroids, what are meteors, what are comets. So again, from basic perspective, we'll develop this understanding. We'll see overall the structure of solar system also. So how it is structured. Then we'll see the different components of the solar system. Then we'll cover important concepts linked to orbits of Earth. low Earth orbit. Then we would see what is geosynchronous orbit. A subset of this is geostationary. Then we would see, I'm writing the short form MEO, medium Earth orbit. Then we would see what are polar orbits. Then sun synchronous orbits. A linked concept that we have to understand is this Lagrange points. आपने आदित्य मिशन का नाम सुना है? आदित्य मिशन, आदित्य मिशन इज अ मिशन ऑफ इंडिया टू सन. पर आदित्य का पूरा नाम क्या है? Aditya L1. So you will hear a term called as 1. So what are these Lagrange points? We should know. So there are 5 such points: L1, L2, L3, L4, L5. Then we would move to technology portion. In technology, we should be knowing about how do we send the satellites. We need engines. We need rocket engines. So you would have heard about cryogenic engine. इंडिया के पास क्रायोजेनिक है पर बनाने में बहुत टाइम लगा था. सो यू शुड नो सम बेसिक एस्पेक्ट्स. सो विल कवर व्हाट आर जेट इंजन्स, व्हाट आर रॉकेट इंजन्स. अ सबसेट ऑफ द रॉकेट इंजन इज क्रायोजेनिक इंजन. तो इसमें क्या यूनिक है, व्हाई इट इज सो कॉवेटेड? सो विल ट्राई टू अंडरस्टैंड. Then we would understand the different launch vehicles of India और इंडिजनाइजेशन एफर्ट भी जो है, जैसे कि हमारे पास अभी PSLV है, GSLV है, SSLV भी डेवलप कर लिया है. वी आर डेवलपिंग RLV, TD, NGLV. So you should have some idea regarding the different launch vehicles. So different launch vehicle use करके different satellites को भेजा जाता है. So we should understand what is the difference between PSLV, GSLV, SSLV. So we'll cover it here. Then we would understand different kinds of space missions. स्पेस मिशंस. तो यहाँ पे हम लोग समझेंगे ऑर्बिटर मिशन क्या होता है, लैंडर मिशन क्या होता है, ह्यूमन मिशंस. डू वी हैव अ प्लान फॉर सेंडिंग ह्यूमंस? इंडिया कौन सा मिशन है? गगनयान मिशन है. सो गगनयान क्या है उसके बेसिक एस्पेक्ट्स डिस्कस कर लेंगे, और प्रीवियस कौन से ह्यूमन मिशंस रहे दैट आल्सो विल डिस्कस. सो विल कवर सम ऑफ द इम्पॉर्टेंट स्पेस मिशंस, पर्टिकुलरली फोकसिंग ऑन द ह्यूमन मिशन पार्ट. Then after this, we would be covering concepts beyond the solar system. So some concepts, theory of relativity समझनी है, मतलब स्पेस टाइम का कॉन्सेप्ट जो आइंस्टीन ने दिया है वो क्या है, कॉन्सेप्ट्स रिलेटेड टू ब्लैक होल, event horizon, singularity. These are terms which has been used by UPSC already. Singularity, gravitational waves. ये आइंस्टीन की 2 थ्योरीज में कवर्ड है, ग्रेविटेशनल वेव्स, वार्म होल्स. So this becomes mostly theoretical understanding that we need to know. और ये ये कवर्ड होता है आइंस्टीन के दो थ्योरीज में, और विल ब्रीफली लुक एट theory of relativity of Einstein, which discusses these concepts. Done? So let's begin with the Big Bang theory itself. What do you know about this theory? क्या है ये theory? It is one of the explanations given to explain how our universe has come into existence. What is this theory saying? क्या बोलता है ये theory? There was something called as singularity. So what is this singularity? So there is something called as singularity. We'll see this term again later. So this theory says that the universe has come into existence from singularity, that there was a point object, very small, size of probably few millimeters only, but it was very dense, and it was very hot also. Thank you. So it was very dense and very hot, and then explosion happened. So when you see this term Big Bang, it refers to the explosion in singularity. Because of the explosion, the universe has come into existence. And you would have also heard that our universe is expanding. Have you come across this term, that our universe is expanding? So initially after explosion, what happened? Initially after explosion, there are many, again, very details given here, but we don't need to cover the most details, but broader understanding is needed. So charged particles were released, electrons, protons were released, and then elements started forming. What is a hydrogen atom? Hydrogen atom is simply a proton, and an electron is revolving around it. So after this Big Bang, after this explosion, these charged particles were released. After some time, when cooling started, then some charged particles like electrons got attracted to protons, and they started revolving around proton. So in this way, hydrogen was formed. So this is the first element in our universe. Hydrogen is the gas, lightest element, and it is the first element. So this was formed. Similarly, helium was also formed. Helium has two protons, two neutrons, and two electrons revolving around it. So after Big Bang, the first few elements that were formed were hydrogen and helium. Now, when hydrogen and helium were formed, there were other particles also that were formed. So cooling then started. When cooling started, what would happen? That matter would also come closer towards each other. What is gravity? Gravity is force of attraction between two particles. If there are two particles, the two particles will attract each other. That is Newton's simple idea of gravity. It is an attractive force, so it will bring things closer. Now when many such hydrogen and helium molecules were formed, or atoms were formed, they started cooling, and then matter would start forming more. So initially, after some time, you would see stars started forming. So stars were formed. We'll exactly see the process of formation of stars, but stars were formed. After formation of stars, then the stars would get attracted to other stars also, and then led to formation of galaxies itself. So later on, after some time, you would see that galaxies started forming. So some spiral galaxies were formed. So these are galaxies that has been formed. And we you also know, or you would have heard, that universe is expanding. So distances between galaxies is increasing. So distances between galaxies, so if this is now, then you would see that the distances between them is increasing. So distances between galaxies is increasing, or we are saying universe is expanding. When did the Big Bang take place? Is there a timeline? So it is said that Big Bang took place 13.8 billion years ago. So if this is now, so we are saying the Big Bang took place 13.8 billion years. I would try to, or we would try to draw lots of diagram, because you will obviously forget the words that you write, but the diagrams will stick to your mind. So it is always better that any is a diagram, whether it is simple, also try to draw it, because at least that would become part of your long-term memory itself. So we say that Big Bang occurred 13.8 billion years ago. If you're saying this is now, or if you're saying this is 13.8, what should I write for T here when the Big Bang took place? क्या लिखना चाहिए? T is equal to 0? No? So can you see that with Big Bang, time also started for our universe? So with the Big Bang, not only matter has started coming into existence, but, or we would say, not only space has started coming into existence, but also time started for our universe. Getting this idea? Do remember this one. So that uh, with Big Bang, time also started for us. Some basic things that you can write for Big Bang theory itself. So you can draw this diagram, then we'll write one or two lines or few lines about or important aspects of Big Bang theory itself. See, my mode of teaching is quite simple. I can always give you a handout, but what I have seen, when I give handout, then you become a Sarkari Babu. You take that handout and keep it in your tables, and you don't study itself. So it is better that you write in class itself. You will be writing less, or we'll cover things slowly, but at least whatever we'll be covering, at least that would stay in your mind. Done? Okay, so you can mention Big Bang is one of the uh, is one of the theories is one of the theories which gives explanation about is one of the theories which gives explanation about origin and evolution, of universe. It gives an explanation about origin and evolution of universe. universe started universe started by an explosion. Universe started by an explosion of singularity. By explosion of singularity. Singularity, just in bracket mention, having very high singularity, is a point object. Singularity, a point object having very high density and very small size. Having very high density and having very small size. Initially the universe was very hot. Initially the universe was very hot. It then started cooling. It then started cooling, leading to leading to formation of leading to formation of elements, leading to formation of elements like hydrogen and helium, leading to formation of elements like hydrogen and helium. Later on, stars were formed. Later on, stars were formed. Then galaxies. It is observed. It is observed that a universe is expanding. That universe is expanding. Next point that you can add, with Big Bang, time also started. So this is an important point that you should note. With Big Bang, time also started for the universe. Time also started for the universe. I mentioned that Big Bang occurred 13.8 billion years ago. That's it. That is mentioned. Big Bang occurred 13.8 billion years ago. See, why scientists have been able to say that something has come out from singularity, because we are observing this part. Universe is constantly expanding. So since universe is expanding, if we reverse and if we go in reverse order, so if we go in reverse, we could see that something could have, or everything could have then emerged from a point object, that is singularity. Our next very simple question to all of you, we are saying, what is gravity? Gravity is force of attraction between two bodies. So one star should have attracted another star, or in other ways, one galaxy should have attracted another galaxy, and both should have merged together. But is that happening? That is not happening. So gravity would have brought things closer, but is gravity not acting then? Are you able to get the question? तो क्या gravity काम नहीं कर रहा है यहाँ पे? Gravity is working, but mass is not sufficient. We are talking about a galaxy. So in galaxy, the mass of the galaxy would be much more. So in our solar system, we have sun as a star, but in a galaxy there could be billions of stars. So galaxy would be heavy from that perspective. So why is one galaxy not able to pull another galaxy? Rather, we are saying they are getting separated out due to distance. So the distance is a factor which is emerging, because or the distance should have changed. Distance should have decreased, but the distance is not decreasing. Hmm. It depends upon R. Okay. So what you're mentioning, let's say there are two objects, M1 and M2. The distance between them is R. Gravity is proportional to multiplication of their masses and inversely proportional to the square of the distance between them. ये स्कूल में पढ़ा होगा, बट ये आपको याद रखने की जरूरत नहीं है. आपको बस इतना याद रखना है, ज़्यादा बड़े मास होंगे तो ज़्यादा फोर्स ऑफ अट्रैक्शन होगा, ज़्यादा डिस्टेंस होगा दोनों के बीच में तो अट्रैक्टिव फोर्स कम होगा, इनवर्सली प्रोपोर्शनल है. सो ग्रेविटी इज एक्टिंग. ग्रेविटी इज अ फोर्स ओनली. हाउ कैन यू काउंटर अ फोर्स? बाय अनदर फोर्स ओनली. इसका मतलब ग्रेविटी काम तो कर रहा है, ग्रेविटी इज एग्जिस्टिंग, बट देर इज समथिंग विच इज मोर पावरफुल देन gravity, and that is causing expansion of the universe. So gravity always acts. It is not that the gravity is not acting, but there is something which is powerful than gravity itself. So there are some hidden things or hidden concepts which scientists have been trying to uncover, that why is universe expanding, who is causing the universe to expand. Gravity should have brought everything to a point object, but it is not happening. There is something more powerful operating behind the scenes. So that is why you should know the next idea, composition of universe. Online students, are you able to understand this? So gravity ऐसा नहीं है कि कम है, gravity ऐसा नहीं है कि act नहीं कर रहा है, gravity act कर रहा है, पर there is something more powerful than gravity which is causing expansion of the universe. We will see what that is. So let's look at composition of universe. Now this diagram is actually a pie chart. So all the galaxies, all stars, everything that you can see, observe, is still real matter, but real matter composition in our total composition of universe is just 5%. Then there is what is called as dark matter, which roughly, or it in fact is at least 5 times more than the real matter. Then the remaining 68%, this is डार्क एनर्जी. तो हमारे यूनिवर्स का जो कॉम्पोजिशन है वो बेसिकली इन 3 चीज़ों में डिवाइडेड है. समथिंग कॉल्ड एज रियल मैटर, something called as dark matter, and then something which is called as energy, dark energy. What is real matter? So are you seeing matter term common in both? बट एक को हम रियल मैटर बोल रहे हैं और दूसरे को हम डार्क मैटर बोल रहे हैं. सो examples of real matter would be anything that you can see: stars, galaxies, planets, asteroids, meteors, living organisms, let's say humans, even black hole would be here. So is there a criteria for something to be called as a real matter? तो ये भी मैटर है, इसके पास मास नहीं है. If you're saying it is a matter, it is having mass. Then what is the difference then? So this is also having mass, this is also having mass. What is the difference then? Is black hole visible? Can be detected, but can you directly see a black hole? It is called as a black hole because you cannot see. This one, you're rightly saying that it is this you cannot see. But there is a different aspect to it. See, why can you see a star? Why can you see a sun? Because a sun is emitting out light. Yes? Why can you see a planet? Why can you see, let's say, Jupiter? Or why can you see moon? Is it emitting out light? No. So it would be reflecting light. So you are able to see. A black hole, why you cannot see a black hole? Because it is absorbing light. It absorbs all the light that you can send. So can you see what is common in them? They are interacting with light. Either they are releasing light, they are reflecting light, or they are absorbing light. Light is called as electromagnetic radiation. Other examples of electromagnetic radiations are gamma rays, X-rays, UV, visible, infrared. So it means when you say real matter will interact with electromagnetic radiation. Or in other simple words, it is either emitting out light, reflecting light, or absorbing light. But dark matter, why it is called as dark? because it is not absorbing, it is not interacting at all. Neither it is releasing light, neither it is reflecting light, neither it is absorbing light. That is why we call such matter as dark matter. Okay, so write a simple definition for real matter. Real matter, matter which interacts, matter which interacts with electromagnetic radiation such as light. Electromagnetic radiation such as light. Full stop. It either emits light, reflects light, or absorbs it. So will this matter have mass? It is made up of mass. So it is, since it is a matter, it also has mass. So mention that it matter, or this real matter has mass. If it has mass, it will also have then gravity. So if it has mass, it can attract other matters also. It has mass, so it also has gravity. Examples of real matter you have already written down. Dark matter, you can write a simple definition of dark matter. See, dark matter, even scientists do not understand it well because not much is known about this dark matter and dark energy. We know very little about it, and that also we can infer. See, you cannot see this because it is not reflecting light, it is not emitting light, it is not absorbing light. So how do we know that it exists? If you cannot see anything, then can you tell that whether it exists or not? You can still say that it exists. Why? Because it has matter, so it will have mass. Since it has mass, it has gravity. And if it has gravity, don't you think it will affect its surrounding? It will start attracting other matters also. Probably it will start attracting real matter also. So by observing the space, we might get an idea about डार्क मैटर ऑल्सो. साइंटिस्ट ने दूसरे तरीके से ढूंढा, उन्होंने गैलेक्सीज का ना मास निकालने की कोशिश करी मैथमेटिकल मॉडल से कि एक गैलेक्सी का कितना मास होना चाहिए, उस मास की वजह से कितनी ग्रेविटी प्रोड्यूस होगी. तो उन्होंने सम करा सारे मासेस का ऑफ रियल मैटर. दे फाउंड आउट दैट द मास इज वेरी लेस कंपेयर टू व्हाट वुड बी द मास नीडेड फॉर मेंटेनिंग द गैलेक्सी. तो एक गैलेक्सी को मेंटेन करने के लिए, इसका मतलब स्टार्स उसी गैलेक्सी में रहे, उन्हीं में ऑर्बिट करें, इसके लिए ज़्यादा ग्रेविटी चाहिए. पर ये सारे का सम करने पे उतनी ग्रेविटी आ ही नहीं रही है. इसका मतलब देयर मस्ट बी समथिंग मोर which is having mass, which is providing gravity, which is keeping all the stars intact within a galaxy. So by that way they have been able to come to know about dark matter. But it is quite difficult to know about dark matter because it hardly interacts with electromagnetic radiation. So you can mention what is dark matter. Matter which does not interact with electromagnetic radiation. Scientists have uh, attempted to calculate scientists have attempted to calculate the total mass of some galaxies, attempted to calculate total mass of some galaxies using mathematical models. They found that gravity provided by real matter they found that gravity provided by real matter would not be sufficient to hold all the matter within a galaxy would not be sufficient to hold all the matter in the galaxy. So they concluded that they concluded that there exists there exists dark matter there exists dark matter which provides the necessary gravity for the galaxy. Next one you can mention dark energy. So here, can you see the term? It's not matter. We are talking now in terms of energy. Energy would be like a force. So this is the energy which is causing what? So gravity is which type of force? Gravity is an attractive force. So dark energy would be which type of force? A repulsive force. And would it be much stronger than gravity itself? Then only the universe is expanding. So now scientists know that there is some kind of energy, but again, we do not know a lot, but at least we know that there is some kind of a force which is much stronger than gravity, which is causing expansion of the universe. So you can mention dark energy. It is the force responsible. It is the force responsible for accelerated expansion of universe. It is the force responsible for accelerated expansion of universe. It is next point. It is opposite in nature to that of gravity. It is opposite in nature to that of gravity, but much stronger than it. But much stronger than it. After these two terms below just mentioned, dark matter and dark energy collectively, dark matter and dark energy collectively is commonly referred as dark universe. And how much is this dark universe in percentage terms? So 95% of our universe is dark for us, or we do not know much about it, is known as dark universe. Also mention this as a note, scientists are trying to understand dark universe. One such example or one such mission to understand dark universe is Euclid mission. We'll study this later, but for now just mention that one such mission is Euclid mission, and its objective is to uncover Euclid mission. So for now just mention Euclid mission is one such mission to uncover dark universe. एक और नेचुरल लॉ है जो आप जानते होंगे, that light is fastest, nothing can travel faster than speed of light. So speed of light is fastest. We can at max travel at speed of light, but as matter, probably it would be very, very difficult to reach speed of light. But there is an exception also. Okay, someday we will see. Okay, so do remember this one, that light is fastest. Coming to our galaxy then, our galaxy is the Milky Way galaxy. It is a spiral galaxy, but for diagram perspective, I'm just drawing it in a circular manner. Imagine There is our sun or our solar system. How old is our solar system, or when was sun formed? Roughly mentioned that 5 billion years old. आपने हिस्ट्री में पढ़ा होगा कि कुछ साइंटिस्ट या कुछ फिलोसफर्स ने बोला कि अर्थ स्टेशनरी है, सन अर्थ के अराउंड घूमता है. दैट वाज द आइडिया इनिशियली, नो, earth centric observation. Then some other scientists, they came and said that no, sun is probably stationary and earth is revolving around sun. Yeah, किसने पहली बार ये बात बोली? गैलीलियो, सो यू वुड बी अवेयर. कॉपरनिकस, गैलीलियो, बहुत सारे साइंटिस्ट, इंडियन साइंटिस्ट बहुत पहले ही बोल चुके थे ये सारी बातें. बट नाउ अगेन अ बेसिक क्वेश्चन. This is established that our earth is revolving around sun. Is sun stationary, or is sun revolving around anything? Yeah, is sun revolving? Yes, no? पूछा ये सवाल खुद से कभी या किसी से? Sun or our entire solar system is also revolving around center of our galaxy. तो सेंटर पे कुछ ऐसी चीज होनी चाहिए ना जो कि सन से भी बड़ी हो और मैसिव हो. Why is Earth revolving around sun? Because sun is the heaviest object for the solar system. So Earth is revolving around it. If you're saying a star is revolving around center of a galaxy, there must be something at the center of the galaxy. So scientists have been able to find that there exist supermassive black holes at center of galaxies. And for our solar system, we have kept a name for it. You might have heard it is called as. So our center, the center of our Milky Way galaxy, has a supermassive black hole which is called as Sagittarius A. And all stars, not only sun, but there are billions of stars in our Milky Way galaxy. They all would be what? Revolving around the center of our Milky Way galaxy. Now, see, the distance here, the numerical value is not important, but this is an astronomical distance. So it is very, very long distance. So what unit do you think we use to measure such long distances? From, if you want to calculate the distance between sun and earth, or between the sun and our center of our galaxy, कौन सा unit use करेंगे? Astronomical unit use करते हैं. So that is called as what? Light year. What is light year? Is it a unit of time or is it a unit of distance? It is a unit of distance. It is the distance traveled by light in 1 year of time. What is speed of light? Okay, so there is a numerical value that you know. Speed of light, is it constant? This speed of light that you write, 3 into 10 to the power 8 meters per second, or if you write it in lakhs term, no? Is it right? This in kilometers per second. Sorry, 3 lakh. Cut this 0 out. So in kilometers per second, it would be 3 lakh kilometers per second. This speed of light, you write, it is true in vacuum. Speed of light is constant only in a particular medium, or in every medium the speed of light would be different. So when light enters from space into our Earth's atmosphere, our Earth atmosphere will slow it down. When light enters into water, it will further slow it down. Light would be 25% slower under in water. In diamond, why does diamond appear shiny? Because diamond holds onto the light. So light crawls inside diamond. So light is very slow inside diamond. So speed of light is not constant. Speed of light depends on the medium where you are measuring it. But can we say for astronomical distances, what is the medium here? The medium is vacuum only, or it is space, so space is vacuum. So can we say safely that the speed of light would be 3 into 10 to the power 8 meters per second? So we can use light year as a unit to measure astronomical distances. The distance roughly, which has been estimated by scientists, is 26,000 light years. So from center of our galaxy, our solar system is roughly around 26,000 light years away. Some questions like this also could be important. Do you think our sun can live for entirety, or do you think our sun will die also? Our sun will die. Why will sun die? The fuel will run out. So when the fuel will run out, it will die. So scientists have said that in 5 billion years, sun has made 20 revolutions around the black hole, and it is estimated that sun will make 20 more revolutions. After 20 more revolutions, it will die. So probably sun will live for more 5 billion years from now. So future of the sun is not very bright. Probably it will die. So we will not be here to witness the death of our star. What will sun form if it dies? ये सुना है या पढ़ा है? Do you think that type of question is important? Yes, that kind of question is important from UPSC perspective, so you should know. We'll deal with that later. So now let's look at how probably our sun could have been born. So we are now delving into the solar system part. Got the idea? So do remember that scientists have been able to find that at center of galaxies there exists supermassive black holes. So this as a line you can mention. Scientists have pointed out scientists have pointed out that at center of every galaxy there exists supermassive black holes. Supermassive black hole, not holes. Supermassive black hole. And mention all stars and all stars and other matters, all stars and other matters would revolve around it. Would revolve around it. Mention also this. Our sun has made 20 revolutions. Our sun has made 20 revolutions around Sagittarius A. It is estimated that the sun will make 20 more revolutions. After that, it would die. After that, it would die. Now let's look at the structure of solar system. Then we'll deal with sun. Have you studied geography? Geography हो गया आप लोग? So उसमें पढ़ा है solar system? नहीं पढ़ा है? Solar systems, Earth के बारे में. So in geography mainly deal with Earth. That I totally understand. But did you study different aspects of planets, asteroids, meteors, and comets? पढ़ा है? Okay. So we will see. What is the outermost part of our solar system called as? The extreme outermost part of our solar system. Let's say here is sun. The extreme outermost part of the solar system. What is this layer called as? No, Oort cloud. So these are some terms that you should be aware. So we'll try to just clarify those terms. Then there is another layer. This layer is called as heliopause. Okay, just to mark this layer. Then there exists a belt which is called as the Kuiper belt. So just to mark it out, this belt is Kuiper belt. Then you have the planets. In between the outer planets and inner planets, there is another belt which is called as the which belt? You see many small objects here which are called as asteroids. So this is the asteroid belt. I'm just marking the initials of the planets: Mercury, Venus, Earth, Mars, Jupiter, Saturn, Uranus, Neptune. Pluto you'll find where? Pluto you'll find in Kuiper belt. Do you think we have gone to Kuiper belt? नासा, इसरो या कोई और स्पेस एजेंसी क्यूपर बेल्ट पहुंचा है? Do you think we are trying to attempt or we are trying to go also outside of our solar system, trying to explore outer planets? Do you think we have missions for Jupiter, Saturn, Uranus, Neptune, and even to Pluto, and going beyond it, which is the most distant object that humans have ever sent? So we are obviously here, we are on Earth. So from this point, we are trying to go to distant places. How far have we gone? What is the best attempt that we have made? We'll see some missions, but for now, remember these two terms: Voyager 1 and Voyager 2. So this has been able to cross heliopause, and we have not been able to go beyond our solar system as of now. तो बहुत डिफिकल्ट है एक्चुअली सोलर सिस्टम के बियॉन्ड जाना. We will see why little later, but let's try to understand the basic physics behind it, or basic aspects of it. The first layer that we can write will begin from outside. Let's write something about Oort cloud. What could be Oort cloud? Is this like a boundary? It is like a boundary only. What is the boundary about? So if you are here, if let's say you are here, you will not feel the gravitational pull of sun. But if you are here, or if you are within this boundary, you'll start feeling the attraction pull of the sun. So what is this Oort cloud? You should write. So you can mention Oort cloud is the outermost layer. Oort cloud is the outermost layer of the solar system. Oort cloud is the outermost layer of the solar system. It is the boundary of sun's gravitational influence. It is the boundary of sun's gravitational influence. It is a source. It is source of some icy objects. It is source of some icy objects that we also call as comets. We'll see comets in more detail later. It is also source of some icy objects such as that is comets. Let's look at this term or this boundary. Whenever you see the term helio is synonymous to sun. So helios or helio is Greek word for sun. So if you see the term helios, heliosphere, it means it is linked with sun only. So we are saying it is also a pause for sun. But which aspect of sun, which effect of sun will you not see beyond this boundary? Now, sun, we will see in some detail little later. Sun is made up of mostly what? Sun is mostly made up of gases. It is mostly made up of hydrogen and helium. So it is mostly made up of these gases. And since sun is very, very hot, so the gases do not exist in normal state. Gas already, it exists in plasma state. What do we mean by plasma? Plasma means superheated state. So if you take hydrogen and if you superheat it, it will rip off the electrons. It means electrons revolving around the nucleus will be ripped off. So electrons will be flowing separately and protons are flowing. H plus का मतलब क्या हो गया? बस proton हो गया. So protons and electrons are flowing. It means sun, you can always think like it is a ball of plasma or it is a ball of charged particles. It is containing protons and electrons and other charged particles also. So do you think this ball of plasma is contained within the sun itself, or do you think it flows out? It flows out. So these charged particles or this plasma, or in other words, charged particles, they are released from sun and they would travel in our solar system. They would go to a particular boundary, but not beyond that. So the boundary for the charged particles up till which it can go is heliopause. Now, when charged particles flow, they create magnetic field. जैसे आपने स्कूल में पढ़ा होगा वायर में जब इलेक्ट्रॉन फ्लो करता है, व्हाट इज इलेक्ट्रिसिटी? Electricity is simply flow of electrons or charged particles. So when a charged particle or electron flows in a wire, it creates magnetic field around itself. So do remember, flow of charged particles will create magnetic field. चार्ज पार्टिकल्स को आप फ्लो कराओगे तो मैग्नेटिक फील्ड प्रोड्यूस करेगा. तो सन्स भी तो चार्ज पार्टिकल्स को फ्लो करा रहा है. सन इज मेकिंग द चार्ज पार्टिकल्स. ओके, हाँ, यू डोंट हैव टू अंडरस्टैंड. So sun is making the charged particles, or the charged particles are emerging from sun and flowing in solar system or flowing in different parts of our solar system. So is these charged particles creating a magnetic field for sun? So yes, it creates a magnetic field for sun. So we can also say that heliopause is boundary of sun's magnetic influence. So it is boundary of the charged particles. It is also the boundary of the magnetic influence of the sun. So heliopause, you can mention what is heliopause. Charged particles from sun, charged particles from sun cannot travel beyond this boundary. Charged particles from sun cannot travel beyond this boundary. Full stop. Flowing charged particles creates magnetic field. Flowing charge particles creates magnetic field. So heliopause is also boundary of. So heliopause is also boundary of sun's magnetic field. So heliopause is also boundary of sun's magnetic field. Next point in this only, sun forms a bubble. Sun forms a bubble of charged particles. Forms a bubble of charged particles from sun originating from sun and reaching up to heliopause and reaching up to heliopause. So if you look from a distance that is quite away from the solar system, so the sun will appear like it is a bubble of charged particles, and it will appear shiny also because these charged particles would be flowing out till the heliopause. So this sphere which is being formed is also called as heliosphere. So this sphere that would be formed is also called as this sphere of charged particles is also called as heliosphere. Next, then mention about this one, Kuiper belt. Kuiper belt. प्लूटो कहाँ पे मिलता है? क्यूपर बेल्ट में मिलता है. So where can you say the what is the location of Kuiper belt? Kuiper belt is beyond Neptune. And is Pluto now being called as a planet or called as dwarf planet? Why it is called as a dwarf planet? Why not a planet? Acha, we'll see. So Kuiper belt. What do you mean by donut shaped? What is donut shape? Any Hindi version of this one? Medu vada. So vada is donut shaped only. So tube like structure with a hole in the center. So this one you can mention Kuiper belt. Kuiper belt is donut shaped region. Kuiper belt is donut shaped region beyond Neptune, beyond the planet Neptune. Donut shaped region beyond the planet Neptune. Next point, some of the dwarf planets are present in Kuiper belt, such as Pluto is one example, but you should find out more. That would be a small homework. And instead of using ChatGPT, it would be better that you use NASA's website. Are you aware about names of other dwarf planets? Or kaun se dwarf planets? You should know the names. Again, these are factual things, but you should be aware. So there exists Pluto, but there are other dwarf planets also. Try to find out the name. Next, asteroid belt. Oh, sorry, Kuiper belt also is source. Kuiper belt is also source of many comets. It is also source of many comets. One mission that you should remember for Kuiper belt, NASA's New Horizon mission. New Horizon mission was sent to Kuiper belt. Was sent to Kuiper belt. ये पुराना मिशन है, but go home and read something about it, or at least write 2 3 important points of this one, like what was the objective this of this mission, and one or two very important findings of this mission. Only few things you have to write. So does Pluto have moons? प्लूटो तो ड्वार्फ प्लैनेट है, ड्वार्फ प्लैनेट का मून हो सकता है क्या? हो सकता है? नहीं हो सकता है? So read about this mission, so you'll get some idea about it also. And it also found out a very interesting body which is called as Ultima Thule. So do read about what is Ultima Thule, which it found out. What is the new name of Ultima Thule? So these are some small see, the purpose of small homeworks is twinfold. पहला तो ये पता चलेगा कि आप घर पे जाके रिवीजन करते हो या नहीं करते हो. So if you're doing your homework, it means at least you have taken the pain to open your notebook and revise it. Also, not everything can be actually discussed in class because we have limited scope and time. So these homeworks are like small guidance or the areas where you should be looking at, because now there is a plethora of information. So these are some areas which you should be looking at, because this will increase your knowledge horizon also. So that is why do take these homeworks seriously. Most of the time you will see some questions are coming from the homework part only that was given. We'll discuss the homeworks, discuss the homeworks, but I want you that you should first find it out, then we'll discuss the homeworks. Done. Asteroid belt we'll be writing later. Now let's write about our star now. Our star is sun. So you should have an idea about, in general, birth of a star. One of the most accepted theory for birth of a star and planets, other objects, is what is called as nebula hypothesis. पढ़ा है ये, पढ़ा होगा. What is nebula? Some pronounce it as nebulae. Nebula is a cloud of dust and gases. So imagine there is a cloud of dust and gases. What would then happen? That some dust particle could act like a nuclei. Nuclei in the sense that it would attract other particles. And if it is attracting, is it gaining mass? If it is gaining mass, is it gaining gravity? It means it will attract more now. So its gravitational pull is increasing. So this ball of mass would keep on becoming bigger and bigger. So it will keep on attracting things around itself. This is known as gravitational compaction. Gravitational compaction or gravitational accretion. तो ग्रेविटी की वजह से चीज़ें पास आती जा रही है, दे आर गेटिंग अट्रैक्टेड, एंड दिस बॉल ऑफ गैस एंड सॉरी द बॉल ऑफ गैस एंड डस्ट इज इंक्रीजिंग इन साइज. क्या ग्रेविटी की वजह से फ्रिक्शन इंक्रीज हो रही है गैसेस मॉलिक्यूल्स और डस्ट मॉलिक्यूल्स के बीच में? What is gravity doing? Is gravity not compressing things? If you decrease the distances between two atoms or two molecules, will the friction between them increase? If the friction increases, the temperature between them will increase. बचपन में आपने जैसे साइकिल में हवा भरी होगी, तो जो पिस्टन सिलेंडर होता है आप उसमें प्रेस करते हो बार बार, तो आपने देखा होगा ट्यूब जो है वो गर्म हो जाती है. Why is the tube getting hotter? Because you are trying to compress the gases. So the gases, the distances between the gases atoms is decreasing. So you are increasing the friction. So due to gravity, you are decreasing the distances or you are increasing the friction. If you increase the friction, will the temperature increase? So is this part becoming hotter and hotter? So because of gravity, yes, the matter is getting compressed, but it is also at the same hand becoming hotter and hotter. And if it is mostly composed of, let's say, hydrogen, so hydrogen, which is a gas, it can happen that the temperature could reach to, or before that, it will form a stage. So this, let me write this stage, then we'll write. It can form a stage just before a star. This stage is called as protostar, where the temperature has increased to very high extent. So it has become very, very hot now. And next stage would be what? The temperature has increased or pressure has increased to such an extent that fusion of hydrogen starts. We'll discuss fusion in more detail just after this only. Uh, at least this you would have heard that hydrogen would fuse to form what? Okay, just to make you aware, in any element that we write, so the top number reflects what? Mass number, and there is a bottom number which is the atomic number. So hydrogen, we say that it will fuse to form helium. So four hydrogen atoms would be fusing to form one helium atom. So during this process, or when this process has started, and when this process would stabilize, then we would say a star is born. So, so in this case, fusion has stabilized. So when the fusion has stabilized, it will start releasing out light and energy. This stage we call as the main sequence star. So when the fusion has stabilized, now you will see that there is continuous release of light and energy. So this stage, we would say that a main sequence star has been born, or this is the stage we are saying that the star has got birth. So for sun, this process or the birth of our sun has happened 5 billion years ago. So our sun was born by this process. Almost all stars or stars would be formed by this process only. So this is the famous nebula hypothesis, which says that how stars are born. Getting the idea? Now let's try to understand fusion little better, because fusion is the source of power for sun. So let's try to understand that part. Done with this diagram? So a small subtopic is what powers sun. What powers sun? So let's write a basic line, then we'll understand this better. What is the mechanism? Fusion. So mention fusion of hydrogen. Fusion of hydrogen into helium is the source of power for sun. Is the source of power for sun. Also mention that Four hydrogen atoms would fuse. Four hydrogen atoms would fuse to form helium. Four hydrogen atoms would fuse to form one helium atom. So we are saying that you would need four hydrogen atoms to fuse to form helium atom. If you look at the nucleus and the structure part, these are, for example, four hydrogen atoms, and we are saying we want to fuse it to create a helium nucleus. But don't you think so that when we try to bring atoms closer, the same charge particles will repel each other? This we know, that same charge particles repel and opposite charge particles attract. So when we try to bring them close, the electrons around the nucleus would try to repel each other. So why will fusion occur? So it could be difficult to do fusion. You have to get rid of the electrons. So we can get rid of the electrons. So now think in this way. Now we are left with protons only, and we are trying to fuse these protons to create helium. Again, same problem will exist, that you're trying to fuse same charge particles, protons and protons. Protons and protons would repel each other. तो fusion कैसे होगा? If all of them are repelling each other, why will fusion occur? Fusion can occur if there is very high pressure and very high temperature applied. So in sun, in the core part of sun, there is very high pressure and very high temperature which can overcome this repulsive force. Then only fusion can occur. So this stage is called as the plasma state. So you have to create the plasma state for fusion to occur. Getting the idea? So mention this, then we'll try to understand it better. For fusion to occur, inside sun, plasma state is required. Plasma state is required. Plasma state, you can write one line. Plasma state is superheated matter. In this case, we are writing superheated gas. Plasma state is superheated gas. In this stage, the gas becomes ionized. The gas becomes ionized. For example, if you superheat hydrogen, it will break into ions, that is protons and electrons. It becomes ionized, or it breaks into protons and electrons, or in this hydrogen case into H plus and electrons. Under high pressure and temperature, fusion of hydrogen, under high pressure and temperature, fusion of hydrogen can take place. Fusion of hydrogen can take place. At such condition, the electromagnetic repulsion between charged particles can be overcome, to cause fusion. Can be overcome to cause fusion. Okay, coming back to here. Let's look from weight perspective. What are we saying? We are fusing 4 hydrogen atoms to get helium. So if I sum up the weights or masses of 4 hydrogen atoms, it should come out to be equal to that of helium. So if I sum up the weight of hydrogen, this is roughly the mass of 4 hydrogen atom. This should have been equal to the atomic mass of helium, but the atomic mass of helium is actually this. What can you see then? Is the sum of hydrogens more than the atomic mass of helium itself? So during fusion, what is happening? There a loss of, there is loss of mass. Can you see there is a drop in mass? There is a loss of mass. So it is this loss of mass which is converted into energy. और ये इक्वेशन आपने स्कूल में देखा होगा अपने फिजिक्स लैब में. ये इक्वेशन क्या है? आइंस्टीन ने दिया था, जो कि सिंपली ये कहता है एनर्जी इज इक्विवेलेंट और mass can be converted into energy. This m here would be delta mass, or here it is loss of mass. What does c stand for? Speed of light in vacuum. इसका वैल्यू आपको पता है, आपको ये नंबर्स भी पता है. यू कैन पुट इन द नंबर्स, यू कैन गेट द वैल्यू ऑफ एनर्जी. एनर्जी का यूनिट क्या होता है? एनर्जी का यूनिट होता है जूल्स. So how much do you think this energy would be? If we are looking at just 4 hydrogen atoms, we are fusing 4 hydrogen atoms and we are getting helium. In just this one fusion process, one fusion means fusion of 4 hydrogen atoms to get helium, how much energy is produced? We can go for mathematical calculations. Scientists have done so, and they give an analogy to understand how much energy would be released. They say that the amount of energy released just by fusion of 4 hydrogen atom can light a 60-watt bulb. So like this bulb, which could be of 40 watts, let's say it is of 60-watt bulb, it can light this bulb for more than 100 years. Just 4 hydrogen atoms. So do you realize the efficiency of production of energy? So fusion of hydrogen is considered to be the most efficient process of energy production. So are we trying to do it on Earth also? Trying to do fusion on Earth? Yes, we are trying to. We'll see that in nuclear science and technology. We'll understand fusion also in nuclear topic. So this you can add. Mention these numbers first, then we'll write about this one. Mention these numbers. These are again rough numbers, not very, very exact, but to give you a broad idea. Mention that during fusion process, there is loss of mass. During fusion process, there is loss of mass, which is converted into energy given by the equation E is equal to mc square. E is equal to mc square. Just mention E stands for energy. Just give me a second, I'm getting a continuous call. What is the last line that you wrote? Given by the equation E is equal to mc square. Now, this equation is very, very popular because it gives an equivalence or equivalence between energy and mass. It is simply saying that mass can be converted into energy, and it could be true vice versa also, that energy can be converted into mass also. So just mention this equation gives equivalence between energy and mass, or establishes equivalence between energy and mass. We'll study a little later in standard model string theory in nuclear science. Everything is actually energy only. Every matter is actually energy only. So we were some form of energy, and now we are converted into mass. And probably when our time is over, we'll again convert back into energy only. So somehow Einstein is trying to point this out. We utilize this equation in fission and fusion processes also. So in fission also this works, in fusion also it works. Okay, so next you can mention, just mention that just fusion of four hydrogen atoms, just fusion of four hydrogen atoms into helium, just fusion of four hydrogen atoms into helium generates generates sufficient energy generates sufficient energy to power, or to light, to power a 60-watt bulb, a 60-watt bulb for more than 100 years. 60-watt bulb for more than 100 years. What is unit of watt? What is watt? Watt का क्या मतलब होता है? If you're saying your bulb is having unit of 60 watts, it is unit of power. It is actually energy consumed per second और पर यूनिट टाइम. तो आपका बल्ब कितनी एनर्जी कंज्यूम कर रहा है पर सेकेंड वाइज, दैट इज कॉल्ड एज वॉट. फ्रॉम पॉलिसी परस्पेक्टिव, सी आपके घरों में बिजली जो लगेगी वो एट मैक्स किलो वॉट में लग सकती है. हाउ मच वुड बी 1 किलो वॉट? 1000 वॉट. हाउ मच इज 1 मेगावाट? हाउ मच इज 1 गीगावाट? तो कंट्री लेवल पे हम वॉट्स में बात नहीं कर सकते, कंट्री लेवल पे किस में बात करेंगे? गीगावाट में. सो हाउ मेनी मेगावाट विल मेक 1 गीगावाट? How much is 1 megawatt? 10 to the power 6 watt is 1 megawatt. And 1 gigawatt, the conversion is 1000. Sorry, 1000 megawatt. 1000 megawatt would make up 1 gigawatt. So this is gigawatt. Or you can say 1 megawatt is also what? 1000 kilowatt would make 1 megawatt. How much do you think India would be producing electricity? कितना electricity produce करता है? 500, roughly around 500. So do remember, India is producing as of now 490 gigawatt of electricity. So these numbers you should try to remember. You should have some ideas regarding it. So we are saying this is the source of power in the sun. Mention then that fusion is technically, or theoretically, fusion is theoretically the most efficient process. It is the most efficient process of energy production. It is called as future of energy. Fusion is called as future of energy. On earth also we are trying to on earth also we are trying to cause fusion in reactors. We'll see that which type of reactor later. On earth also we are trying to cause fusion in some reactors. Next, let's see structure of sun or different layers of sun. Some brief idea we should have. So imagine if this is sun. So we would say that two broad layers, there is something called as outer layer, and then there is something called as inner layer. In inner layer we have three layers. So this layer we are calling as the radiative zone. This layer you can see convection currents. It is called as convective zone. So just to highlight that this is the layer. Then we have what appears to be the surface of sun. This is called as photosphere. Then there is this thin layer which is called as chromosphere, and then the outermost layer. So this layer is called as corona. Just give me a okay, so sorry for that disturbance. Let's write about the different layers. The most important layer obviously is the core part. So this is the layer where fusion is taking place. So fusion is occurring in the core part. So will this part be the hottest part then of the sun? Because it would be generating a lot of heat and energy. So this part would be, or it is the hottest part. And as you move outwards, the temperature would drop. So the outer layers would have lesser temperature. But what we see that the temperature, yes, it falls from core to outer layer till photosphere. But after photosphere, we start seeing that the temperature starts to pick up, or the outer layer, which is the corona, is hotter than the previous layer, chromosphere. Scientists do not understand it well. We are trying to, so in all the solar missions, one objective of the solar mission would definitely be to find out why the outer layer of corona is hotter than the previous layer, because we are not able to explain this temperature inversion. So generally it should, the outermost layer should have been the coldest layer, but that is not the case. The coldest layer is actually this layer, which is the photosphere. So why it is called as photosphere? Photosphere is again taken from the Greek word photo. Photo means light. So when you see the sun, you cannot see this layer, the outermost layer, and the chromosphere. What you see is actually the photosphere. So sun, when you say it is appearing orangish or reddish, is actually this. And is sun having a surface? sun तो mostly क्या है? हाँ, sun is mostly gas only. If sun is mostly gas, it will it have a surface? Earth will have a surface, or planets can have a surface, but sun is not having surface. Acha, in fusion part, one more thing that you can add, composition of sun, or what is the sun made up of? So sun mostly is hydrogen. It contains mostly hydrogen. It contains helium about 23%. Then it contains some heavy metals, which is about 2%. क्या ये रेशियो फिक्स रहेगा फ्यूचर में भी? Why? Because hydrogen is getting converted into helium. So this percentage in future would change. Amount of hydrogen would decrease, क्योंकि हाइड्रोजन फ्यूज कर रहा है क्या बनने के लिए? हीलियम बनने के लिए. So the percentage of helium would increase. Can it reach to a point where 0 percentage, or all the helium, or sorry, all the hydrogen has got exhausted? Getting it? So at this point, when all hydrogen has got exhausted, we will say that our sun will die. You could have asked a question, तो हीलियम का फ्यूजन नहीं हो सकता है क्या? हाइड्रोजन का फ्यूजन हो रहा है तो सन को पावर मिल रही है, तो हीलियम का भी फ्यूजन करके कुछ बना लेंगे, हीलियम को फ्यूज करके कार्बन बना लेंगे. But the mass of sun is not so high that during its lifetime, when it is alive, it cannot cause fusion of helium. For fusion of helium, much higher pressure and much higher temperature is needed, which is not provided by the present sun. So fusion of helium cannot take place. So it is like end stage for hydrogen. So hydrogen can fuse to form helium, but helium can further not fuse while sun is alive. Getting this? So just mention this aspect. The ratio would keep on changing, and sun would die also if hydrogen gets exhausted. Okay, coming back to the layers. So first layer that we can write is core part. Core. Core. Core you can write. Do you think or yeah, go ahead. So, what do you mean by heavy metal? What is? Heavy metal. Ha. See, in our periodic table, there are most of the metals which are actually heavy metals only. So iron, nickel, cobalt, all these would be falling under heavy metals only. So lithium is not a heavy metal. Lithium is one of the lightest metal. So sun, because it is having very high mass, so it would also be having some metals which would be having very high density. So heavy metals, simply understand for now that they are having high density. For example, iron is having higher density than compared to other metals. Okay, coming to this part, core. Core, what did you write anything? So core. Do you realize that it is, since it is the innermost part, the density will be maximum here because gravity would have compressed everything here. So would it be the densest layer? Yes, it would be the densest layer. It is the hottest layer because fusion is taking place. So just mention that fusion of hydrogen into helium takes place. Fusion of hydrogen into helium takes place in the core. This process, this process makes this layer. This process makes this layer the hottest layer. This process makes this layer the hottest layer. Uh, heat from the core. Heat from the core would travel outwards. Heat from the core would travel outwards. Next, in the core, in the core, there is sufficient pressure and temperature. In the core, there is sufficient pressure and temperature to cause fusion of hydrogen, but not of helium. But not of helium. Fusion of hydrogen can happen, but not that of helium. Next, these two layers you can write together, radiative zone and convective zone together. Radiative zone and convective zone together. You understand these terms, radiation and convection? Conduction, convection, radiation. क्या होते हैं ये सारे? Modes of heat transfer. Conduction means what? Let's say you're cooking tea or you're making tea. So if you directly touch the handle of the kettle, heat will be transferred from, yeah, from higher temperature to your body. So heat is transferring by direct contact. That is called as conduction. What is convection? Rising of fluid. Would it be only fluid or can it be gases also? It can be gases also. जैसे storms या winds कैसे बनते हैं? So Earth's surface would be hotter, so it would heat up the air above. So the air above, just immediately above the surface, would rise up. Upper layers are colder; they would sink down. So there is a circulatory movement happening because of this. Yeah. So example would be when you're cooking tea also. Water, the lower layer would get heated up. It would move up. The density would decrease. The upper layer would move down. So there is a convection current which is occurring inside the kettle itself. Radiation. So in convection, you need a medium of heat transfer. So their heat would be transferred from high energy to lower energy or from higher temperature to lower temperature, but by using of a medium or via a medium. What is radiation? You don't need a medium. So you receive heat from sun. So most of the heat or the heat part is traveling in vacuum only. So it is transfer of heat without the need of medium. So in sun also you will see there are different layers. So heat is being transferred by different mechanisms. Only this much is important. So you can just mention now these two layers, these two layers transfers the heat. These two layers transfers the heat from the core to outer layers, transfers the heat from core to outer layers process of via process of radiation and convection, via process of radiation and convection respectively. Via process of radiation and convection respectively. Next one you can mention photosphere. Photosphere. It is the visible part of sun. Photosphere is the visible part of sun. It appears to have a surface. It appears to have a surface. It is the coldest layer of sun. It is the coldest layer of sun. The temperature here could be in the range of thousands, 5500 degrees Fahrenheit. Here in the core part, it could be few million degrees Fahrenheit. Exact temperature is not very important, but the core part, the temperature would be in million degrees Fahrenheit. It would drop to few thousands only in the photosphere. So this is the coldest layer of sun. Next, uh, sunspots are observed. Sunspots are observed in this layer. Sunspots are observed in this layer. Sunspots, what are sunspots? You can write darker portions of the sun. Darker portions of the sun which are colder than its surroundings. Darker portions of the sun which are colder than its surroundings. Full stop. The number of sunspots is dynamic. The number of sunspots is dynamic. It depends upon solar cycle. We'll see all these terms, solar cycle, a little later. It depends upon solar cycles. We'll see what is solar cycle also a little later. Next one. So after photosphere, you can mention chromosphere. Chromosphere. It is a thin layer. Chromosphere, it is a thin layer, but it has very strong magnetic field. It is a thin layer, but it has very strong magnetic field. This layer controls the flow of plasma. This layer controls the flow of plasma. This layer is not visible by naked eyes. This layer is not visible by naked eyes. Next layer that you can mention is the outermost layer, that is corona. Corona, it is the outermost layer. Corona is the outermost layer. Next, it is the least dense layer of sun. It is the least dense layer of sun. Its temperature is hotter. Its temperature is hotter than the previous layers. Is hotter than previous layers. In bracket mention not hotter than core. Its temperature is hotter than previous layers, not hotter than core. But temperature reaches to about million degrees. So it would be in some million degrees. Temperature reaches to about few million degrees Fahrenheit. It is also not visible by naked eyes. The outermost layer is also not visible by naked eyes. It is visible during it is visible during solar eclipses. It is visible during solar eclipses. So in a solar eclipse, you would be aware a moon would come in between. So a ring would be formed, an outer ring would be formed. Then we can see the corona part. Normally, we cannot see the corona part. Next, you can mention this phenomena. We should understand what do we mean by solar cycles or solar cycle. Have you come across this term, solar cycle? You would have studied about magnetism या magnets के बारे में कुछ पता होगा. A bar magnet, this is an example of a bar magnet. In a bar magnet, it would be having magnetic field lines. So field lines, so like this we represent. I hope you would have remembered from school something. तो नॉर्थ पोल से मैग्नेटिक लाइंस निकलते हैं और वो साउथ पोल की तरफ एंटर करते हैं. सो अ मैग्नेट हैज़ अ मैग्नेटिक नॉर्थ पोल. सो दिस इज called as the north pole of the magnet, and then it has, sorry, this is south, and this is the south pole. In geography you would have studied about the poles. Earth is also having magnetic field. Earth is also having magnetic north pole and magnetic south pole. Does the magnetic north pole and south pole flip? It means the north pole becomes the south pole and the south pole becomes the north pole. So for earth that is true. पढ़ा है शायद. So the north pole would become the south pole and the south pole would become the north pole. Do you think it would be true even for sun? Sun is also, in fact, sun is the most powerful magnet for our solar system. So in sun also we have what we call as the magnetic north pole and the magnetic south pole. For earth, the flipping of the magnetic north pole and south pole can take thousands of years. It can take around 20,000 years, 20 to 30 thousands of years, even more also in some cases. But on sun, the flipping of the magnetic north pole and the magnetic south pole takes place very frequently, and that frequency is hardly 11 years. So in every 11 years, so the sun's magnetic north pole becomes the south pole and vice versa. And when its magnetic poles flip, the sun behaves differently. So in between this phase, there would be a period which is called as solar maximum, and there would be a phase which is called as solar minimum. Solar maximum means sun is very active during this phase, during the solar maximum phase. Very active, what it means, I'll have to take this call. Okay, coming back to here. So we are saying that in case of sun, the magnetic north pole and south pole flips very frequently, and in that period, 11-year period, you will see that sun will experience different phases. When you say it will experience solar maximum, what do we mean by that? What we can do to visualize this one? Uh, there was a video released by NASA this video you can just see to get an idea. So a mission of NASA was sent way back in 1993, and this mission has observed sun for roughly around 20 more than 25 years. So what you're going to see, NASA had sent a mission called as SOHO, Solar and Heliospheric Observatory. So they had sent it way back in 1993. The mission was about to get over in 3 years of time, but it has survived. It has survived till this year also, 2025. So for very long, they have observed sun, and they have video recorded the activities of a sun. So in this video, you'll get an idea about what is the sun doing. Sun releases out charged particles, as we have mentioned. Sun releases out plasma or charged particles, but the release is not like it is a regular wind. So sometimes the sun is very active, sometimes the sun is not so active. So sometimes you'll see some sporadic eruptions also happening. So when will that sporadic eruptions be more? You can get an idea here. Also, do keep a note. Do you think sun is also spinning on its axis? Sun, we said, is revolving around the center of our galaxy. Is sun also spinning on its axis? You'll get a visual idea about that also.
All of the 8 large planets in the solar system orbit the sun in a plane that lies within a few degrees of the Earth's orbital plane, the so-called ecliptic.
So what you are seeing in this video, we have created like a solar eclipse situation. We have blocked out the main part of the sun. What we are trying to look at is the outer layers of the sun. And can you see sun is releasing out some kind of light and energy and some charged particles into space, and this release is not constant, it is very very dynamic. What you're seeing here is this is a planet which is revolving around a sun.
So when we observe the sun with a coronagraph that blocks the much brighter light from the sun itself, so we can see the faint corona, the sun's hot outermost.
Can you see these bursts of energy and charged particles?
And this remarkable series of images, we actually get to see several different planets. And also in the upper left of the image, you can see the Pleiades, the star cluster. The images of planets come out here looking as though they have horizontal streaks because they're so bright that they overwhelm the electronics in the detector that's taking this image. SOHO's extreme ultraviolet telescope allows us to see a variety.
Is it spinning?
Some of the most intense
in which direction?
Fall 2003, which is a bit of a surprise.
Anti-clockwise, west to east, we can say, anti-clockwise.
Solar activity side. So beautiful clip, and it shows what SOHO's extreme ultraviolet.
Can you see some dark spots?
So what we're seeing here is those same periods of activity in the fall of 2003, only this time from SOHO's coronagraph.
So you can see that sun will not behave same throughout its existence. Sometimes it will behave differently, and it depends upon what? Solar cycles itself. So you can mention what do you mean by solar cycle? Magnetic poles of sun. Magnetic poles of sun flips in every 11 years. Flips in every 11 years. That is, the north pole becomes the south pole. The magnetic north pole becomes the south pole, and vice versa. The magnetic north pole becomes the south pole, and vice versa. During this period, sun enters into solar maximum phase and solar minimum phase. Sun enters into solar maximum phase and solar minimum phase. During solar max, during solar max, there is increased activity observed in sun. During solar max, there is increased activity observed in sun. Hyphen, more solar storms or flares, coronal mass ejections are observed. More solar flares or solar storms or coronal mass ejection. We use the term coronal mass ejection. What does this simply mean? CMEs, जो चार्ज पार्टिकल्स है वो कोरोना पार्ट से निकलते हैं, इसलिए इसको कोरोनल मास इजेक्शंस बोलते हैं. सो सन इज रिलीजिंग आउट मोर चार्ज पार्टिकल्स during the solar maximum phase. In that video, you would have got some idea that sun is there is a sporadic or sudden burst of energy that we are calling as solar storms or solar flares. What is the linkage between solar max and sunspots? ये तो आपने बोल दिया कि सोलर मैक्स में ज़्यादा सन की एक्टिविटी है तो ज़्यादा आपको विंड्स और स्टॉर्म्स और कोरोनल मास इजेक्शंस दिखेंगे. व्हाट अबाउट सन स्पॉट्स? व्हाट डिड यू मेंशन आर सन स्पॉट्स? Absence of flare, or we are saying they are colder portions surrounding, so they are appearing dark, so they are colder portion. And we also said the sunspots, the number of sunspot is dynamic. It depends on solar cycles. So will the number of sunspots be more or less during max period? Less during max or more during max? Less sunspots. Why? If more activity is happening, are we not saying that sun is releasing or throwing out more particles? So is it losing more particles, more charged particles? So will there be more colder sections now in the sun? Is it not giving away particles? If you're saying it is in solar maximum, it is releasing out the particles in the solar system. So there would be more colder spots. So the number of sunspots would be more. Getting it? So mention this correlation. During solar max, the number of sunspots would increase. During solar max, the number of sunspots would increase. As sun is releasing more particles and energy, what is the line that you wrote? Increase during solar max. As sun releases out more charged particles and energy, colder sections would increase. Colder sections would increase. Colder sections would increase. We can say the reverse for solar min. Solar minimum or solar min. Just mention one line, reduced activity of sun. So during the solar min phase, there would be reduced activity of sun. And the number of sunspots would also be less. So a simple correlation. During solar max, more number of storms and more number of sunspots. So just remember this simple correlation. So during solar max, more storms, more sunspots. And solar minimum, less number of solar storms and lesser number of sunspots also. Got the idea? Okay. Now, you would have read about auroras. Auroras. We'll also briefly discuss about auroras because there are different dimensions to that. So we'll try to cover the basic fundamental process. So next important concept that you have to understand is magnetic reconnection. Yeah. Why is the radiative zone coming? Okay, that is an interesting question. I'll have to cross check that why that layering in that sequence. Yeah, so there is an order. Yeah, there is an order to it. I'll look for. I know one reason I can think of, but let me read more and get a better answer. Then I'll come back to it. Coming to magnetic reconnection. Now, what do you mean by this magnetic reconnection? Sun is also a magnet, and Earth is also a magnet. So these two objects, they can interact with each other, or the magnetic field of sun would interact with magnetic field of earth, and not only of earth, for any planet which is having a magnetic field. So that process is called as magnetic reconnection. So you can write a simple line, then we'll see through diagram. Magnetic reconnection, it is a fundamental process. Magnetic reconnection, it is a fundamental process in which magnetic field of sun and planet magnetic field of sun and planet would interact with each other. Magnetic field of sun and planet would interact with each other to explosively transfer light and energy, to explosively transfer light and energy. It is this phenomena, which is responsible for causing it is this phenomena which is responsible for causing auroras on planets. So let's say if this is a sun, it is releasing these charged particles. If this is earth, earth is having magnetic field, and the magnetic field creates a shield for it. So this is the magnetic shield. So most of the charged particles, they are deflected away, but some charged particles, they are able to enter the polar regions. This you would be aware? No? अर्थ का मैग्नेटिक नॉर्थ किधर है? Where is the Earth's magnet's north pole? अच्छा, let's look at this one first. Done with the diagram? Okay. Uh, just a sec. So you can mention some basic aspects to this one. Mention Earth's magnetic field. Earth's magnetic field creates a magnetic shield. Earth's magnetic field creates a magnetic shield which acts like a funnel, which acts like a funnel to deflect away which acts like a funnel to deflect away charged particles coming from sun towards the polar regions. Towards the polar regions. Next, when these charged particles enter Earth's atmosphere, when these charged particles enter Earth's atmosphere, they interact with atmospheric gases. They interact with atmospheric gases to produce colored night sky, which is called as auroras. So in northern hemisphere, we see or we call the phenomena as aurora borealis. In southern hemisphere, we call it as aurora australis or southern lights. ये पढ़ा होगा आपने कि कौन कौन से कलर प्रोड्यूस होते हैं, ऑक्सीजन के साथ रिएक्ट होता है तो कौन सा कलर प्रोड्यूस होता है. नो, ट्राई टू फाइंड इट आउट. हाँ, विथ ऑक्सीजन इट विल प्रोड्यूस विच कलर? ग्रीन. These you would have studied, so that is a small homework for you. So how is green color produced, how is red color produced, purple, blue, how those colors are produced, which gases would produce which colors, this you can read more. A more basic question is, do you think all planets have auroras? So write this as a homework. Do all planets have auroras? Do all planets have auroras? So you actually need two conditions for auroras, for a planet to have auroras. First is that the planet should be having magnetic field, and second, it should be having an atmosphere. So you basically have to find which planet does not have magnetic field, which planet is not having atmosphere. Well, most of the planets are having atmosphere, but try to read something about it. So you have to find out which planets do not have auroras. Also find out which planet has the strongest aurora. Which planet do you think has the strongest aurora? No? That also is a homework then. Find out which planet out of the 8 planets has the strongest aurora. Now we need to understand one more critical aspect here. Let's say sun is in this period, solar max phase. This diagram that we have drawn is probably for a normal situation, but during solar max, what could be happening? That sun is releasing out more solar particles or more charged particles. There could be more solar storms or sudden eruptions of energy. So this shield is deflecting away most of the charged particles. So the shield, Earth's magnetic shield, is a protective layer. If this shield was not there, life could not have existed. So this shield is important. But during solar max, it might be possible that some of the charged particles might not get deflected away because the number of charged particles or the amount of charged particle, volume of charged particle is very, very high. So the shield might not be able to deflect away most of it. Some part of it could reach other areas of Earth also. It means, then can you observe auroras in regions other than the polar regions? So during solar max, during intense solar activities, it might be possible that you start observing auroras in other parts of the world also. What other impacts could be possible because of solar winds or solar storms? Satellites are orbiting Earth. We'll study about satellites and different types of orbits separately. Let's say there is a satellite. Do you think the satellite paths could be affected by solar storm? Satellite path could be affected, its orbit can change, it can itself get destroyed also. That can also happen if astronauts are staying here, for example in the International Space Station. So can astronauts life be threatened by solar storms or solar winds? If we are trying to send some mission from Earth to, let's say, towards sun, or even towards outer planets, do you think we should be careful about what phase the sun is in? Yes, for any space mission, you should be tracking how or what the sun is doing or in which phase it is. Do you think it can affect telecommunication system also? Solar storms, because telecommunication systems are dependent upon satellites only. So satellites could disturb or get disturbed. So telecommunication system could get disturbed. Aeroplanes, which are particularly flying over the polar regions, do you think their communication could also get disturbed or interrupted? Yes, that could also be possible. What do you mean by grid system? Sorry, electrical grid. So we're talking about electrical grid. Power we supply through grids. So we produce power in some, let's say, thermal power plants or hydroelectric power plants. Then we extract the power from there through wires, and then we have grids. So grids would supply power to different sectors or different regions also. So grid that we have is an open system. So electrons are flowing in the wires or in the grids. Do you think charged particles coming from the sun can affect the grids also? Yes, so the charged particles coming from sun can affect the grids also, which are on Earth. So grids can also be affected by solar storms or solar winds also. Do you think these charged particles from sun, can it cause forest fires also? Charged particles coming from sun? Forest fire, so you would have read some materials, particularly leaves of pine trees, they are highly combustible, they just need some ignition and they can start burning. So these charged particles, you can think of them like an igniter or spark plugs. So they will cause a spark in some materials and it can cause forest fires, but it might not be able to cause forest fire in the entire earth, because for forest fire to sustain, you need other supporting materials also, you need supporting environment also. It should not be raining. In tropical regions it would rain every day, in equatorial belt it will rain every day, so forest fire cannot occur in all parts of the world. In some parts definitely it can start forest fire also. Got the idea? So you can mention then impact of solar storm. Impact of solar storm. Bracket major solar storms. Impact of major solar storms. First point, auroras can be observed. Auroras can be observed over much of the planet. Auroras can be observed over much of the planet. Next, satellites could be destroyed. Satellites could be destroyed. You would have heard about Starship program. Not Starship, sorry, Starlink. Starship भी है उनका. Starlink program of Elon Musk. So he's trying to provide internet using satellite. So his some of the satellites got burnt out because of this only. Okay, so you can mention this as an example. Some of the satellites of the Starlink project. Just a second. Some of the satellites of the Starlink project got destroyed by solar storms or solar winds. Solar storms would be a better word. Next, satellites orbits could get altered. Satellites orbits could get altered or changed. Next, telecommunication networks could get disturbed. Telecommunication systems could get disturbed or affected, especially especially ov- especially in the polar regions. Especially in the polar regions. Next, forest fires could occur. Forest fires could occur in some places on Earth. Could occur in some places on Earth. Then mention grid system could also get affected. Grid system could also get affected. Grid in bracket mention electrical grid system. Grid power grid system. Electrical or power grid system could get affected by major solar storms or solar winds. Done. So we have briefly discussed about sun, how it was born, what it is doing, and we'll discuss later what it will do when it will die. Uh, Planets, just some brief aspects you should know. Why is Pluto now called as a dwarf planet? Previously, it was called as a planet. Which body determines which body can be called as a planet or not? There is a body, International Astronomical Union, and according to that, there is a definition, or a planet must be doing or meeting some criterias for it to be called as a planet. What are those three criterias? A planet should have moon. तो प्लूटो के पास मून है. प्लूटो के पास मून नहीं है. मर्क्यूरी के पास मून है. Is Mercury having moon? Mercury is not having moon. But is Mercury a planet? Yes, Mercury is a planet. So for very long, Pluto was considered as a planet, but now we call it as dwarf planet. What happened in 2006, which made it a dwarf planet? So from 1930s onward till 2006, it was being called as a planet. But in 2006, we came up with some criteria and it fails or it is not able to meet one such criteria. So we are not calling it as a planet, we are calling it as a dwarf planet. क्या criterias हैं? अच्छा नहीं पता है ये? अच्छा चलो लिख लो फिर ये एनसीईआरटी में भी mentioned है आपके, but let's write it down. According to International Astronomical Union, 2006, a planet must do three things. According to International Astronomical Union, a planet must do three things. First, it must orbit. First criteria, it must orbit a star. In our case, the star is sun, bracket sun. It must orbit a star. In our case, it is sun. Second, it should have enough gravity. It should have enough gravity that it has shaped itself. It has shaped itself into spherical shape. It should have enough gravity so that it has shaped itself into spherical shape. Third criteria, it must have it must have cleared its orbit around the star bracket sun. It must have cleared its orbit around the star bracket sun of, so this is an important keyword, of similar sized objects. This is an important keyword. What this simply means, can anyone explain what this means? It means if Earth is revolving in an orbit around Sun, there should be no other body which is similar size to that of Earth. Then Earth you cannot call as a planet. So for Pluto, we are experiencing this problem that Pluto meets this criteria, Pluto meets this criteria also, but Pluto fails to meet the third criteria. It has not cleared its orbit. It means there are similar sized objects in orbit of Pluto around Sun. So Pluto fails to meet this criteria. So we have started calling Pluto as a dwarf planet. So you can write this also below this one. Pluto Pluto fails to meet the third criteria. Pluto fails to meet the third criteria as it has not cleared its orbit. As it has not cleared its orbit around Sun. As it has not cleared its orbit around Sun. So from 2006 onwards, it is called as, so it is called as dwarf planet. In fact, Pluto also has moons. Pluto has 2 moons, but still we are not calling it as planet because it is not able to clear its orbit. जैसे पॉलिटी में आपने कॉन्सेप्ट सुना होगा सॉवरेनिटी का, मतलब अपने ऑर्बिट में इसके अलावा और कोई इसके इतना पावरफुल या केपेबल या इतना साइज का नहीं होना चाहिए. दैट इज द आइडिया ऑफ द थर्ड पॉइंट. Have you noticed what is the direction of movement? So in planets we use the term revolution and we use the term rotation. What do you mean by revolution and rotation? Revolution is around the sun. Rotation is about its own axis. So what is the direction of revolution of all planets around sun? So there is a term that you will see. There is something called as prograde direction. Prograde direction for our solar system is anti-clockwise direction, or we would say west to east direction, and then the reverse of this is called as retrograde direction, which is obviously clockwise or east to west. क्या लगता है आपको कि प्लैनेट्स किस डायरेक्शन में रिवॉल्व कर रहे हैं? All planets, some planets, all, some. Some is safer option. then compared to all. What about rotation? What about rotation of the planets on their or on their axis? Are they rotating in anti-clockwise direction or clockwise direction? Anti-clockwise direction, all. So mention this, that all planets, all planets are revolving around sun in prograde direction. All planets are revolving around sun in prograde direction. What do you mean by prograde? Mention that. Anti-clockwise direction. ये सिंपल है, याद रखना. हाँ, mention next. Most planets are revolve, oh sorry, not revolving. Most planets are rotating on their axis. Are rotating on their axis in prograde direction, except are rotating in prograde direction except, कोई exception है? Venus and Uranus. Except Venus and Uranus. Can you see a linkage between the video that you saw and what we have mentioned now? Sun कैसे rotate कर रहा था? Was it rotating in west to east direction that you saw? No? So try to find out the linkage between rotation of sun and this prograde direction for the solar system itself. अच्छा, Kepler's law of planetary motion पढ़ा है? Kepler's law. अच्छा, just for those who are not aware, our sun, it's so this is, let's say, center. This is an ellipse. If you elongate a circle, you will get an ellipse. So this is one of the focus. This is another focus. You have to assume that sun is here at one of the focus of the ellipse, and the planet is revolving around sun in not perfect circular path, but rather in an elliptical path. So can you see that distance between sun and the planet, it's not same around or during the revolution time. So sometimes the length could be very high, sometimes the length could be very less also. So what is this maximum length called as? Perihelion, एपिहीलियन, एपिहीलियन. हाँ, क्यों कंफ्यूजन है? क्योंकि दोनों याद रखा है, पेरिहिलियन भी याद रखा है, एपिहीलियन भी याद रखा है. Farthest is epiheelian. Okay. How have you remembered it? जो अवे है, जो पॉइंट अवे है वो अपिहीलियन है. No? Simple some mnemonics for your brain, because you have to keep a lot of information in your brain. So one which is the furthest most point would be the epiheelion. So the closer point would be called as? Again, can you see the term? Helion with respect to sun. तो वैसे ही आप अर्थ भी ले सकते हो और मून भी ले सकते हो. मून इज रिवॉल्विंग अराउंड अर्थ, so there would be a longer distance, there will be a shorter distance. So आप फिर term use करोगे apogee, perigee. So for satellites also we'll be starting, you'll use that kind of term. Now another simple question. So you are saying that the distance between the planet and sun is not same. It depends. It sometimes it could be more, sometimes it could be less. Where will the speed of the planet be maximum? Will the speed be different? Speed of the planet at this point, let's say speed here, sorry, speed at ephelion and speed at perihelion, where would the planet be the fastest? Near the sun, it would be the fastest, or away from the sun, would it be the fastest? Away, it should be fastest. Yeah, your logic. So you are saying it is fastest here. Why? Your logic. Gravitational pull of push of sun. Gravity is always an attractive force, so you cannot actually say push. Okay, so what we'll do, we'll take it from here only tomorrow. Okay, try to find it out, otherwise we'll discuss. Okay, so thank you all. If you have any doubt, you can ask. Online students. What is the reason? The reason for solar cycle is flipping of the magnetic poles. Now you can ask a basic question, why the poles flip? In Earth also you would have asked this reason that the poles flip. Is there a reason for flipping of the poles? What is the reason for flipping of the poles for Earth? The Earth's magnetic field is produced by convectional currents. There are convectional currents in occurring inside the occurring inside Earth. So the movement of the liquids, the pattern of the liquid would change after some time. Similarly, the flow of charged particles inside sun is changing. The pattern of flow inside sun is changing. So because the pattern changes, so the north pole would flip or south pole would flip. So it is because of the flow of the charged particles itself. Yeah, you were asking. Hmm. Due to pressure and temperature. Where it come from? Yes, that would be a good question. So you can simply say it would have come from the starting point itself. जैसे कि ये बिग बैंग हुआ है, the very first slide. So you are reaching to a point where आपने यहाँ पे नहीं पूछा कि ये एक्सप्लोजन क्यों हुआ. ये भी तो पूछ सकते हैं ना कि एक्सप्लोजन क्यों हुआ. So science can explain that how universe has come into existence. Science might not be able to explain why it has come into existence. तो ये एक्सप्लोजन हुआ है, पर ये किसने करा है, क्या फैक्टर था कि जिसके वजह से एक्सप्लोजन हुआ है. So science might not have an answer to such type of question as of now. So this would be the practical limitation of the science as of now. Again, coming to sun. So sun is formed from what? After Big Bang only. So Big Bang is the driving force for most of our stars and galaxy. So the residual heat that a sun would have got, or the initial heat that it would have got, would probably be coming from the, yeah, start itself, start of the Big Bang itself. Okay. Any other doubt? Yeah, one hand is raised. Yeah, Nandana, go ahead. Hmm. No, no, you don't have to remember the time period. UPSC is not into factuality, too much factuality, until unless there is some concept embedded in it. So if there is a concept, then they could ask the timeline. Otherwise, the timelines are not being asked. I haven't seen such questions in UPSC from or since the, if you check PYQs, 25 years PYQ, they won't ask such questions. If there is a concept, then they could ask. Yeah. Huh. Are we purposely leaving the boson field? Yeah. So boson. So you are entering into a different realm itself. So that is quantum physics, and you are trying to merge it with space. So it becomes a difficult branch of science in itself. So there are complexities. So we'll do that in nuclear. In nuclear, we'll understand boson and boson field. Here, we'll try to understand space-time. Einstein ने जो बातें कही थी. Okay, any other doubt, online students? No. So we'll close the class then. Yeah, yeah. Go ahead. Go ahead. सर ये जो dwarf planet है और सर planet है ये दोनों अलग dwarf planet और जो सिर्फ planet है वो planet के अंदर भी नहीं आते बिल्कुल separate करके रखा है उनको सेपरेट कैटेगरी में डाला गया है एक प्रैक्टिकल रीज़न था क्योंकि 2000 या उससे जस्ट बाद बहुत सारे ऐसे एस्ट्रोनॉमिकल ऑब्जेक्ट्स हम ऑब्जर्व कर रहे थे और हमें बहुत सारे ऐसे नए नए ऑब्जेक्ट्स भी मिल रहे थे एंड दे ऑल वर स्फेरिकल इन शेप दे ऑल आर ऑर्बिटिंग सन तो आपको या तो फिर प्लैनेट की लिस्ट बढ़ानी पड़ती या फिर आपको एक एक्सक्लूजनरी क्राइटेरिया क्रिएट करना पड़ेगा तो फिर साइंटिस्ट ने क्या करा एक एक्सक्लूजनरी प्रिंसिपल डाल दिया कि अपने ऑर्बिट में यही सिर्फ होना चाहिए इसके अलावा इसके सिमिलर साइज का ऑब्जेक्ट नहीं होना चाहिए तो और जो ऑब्जेक्ट्स डिस्कवर हुए हैं 2006 ऑनवर्ड्स यू विल सी दैट दे वुड फेल टू मीट द थर्ड क्राइटेरिया so we have kept a separate category altogether for dwarf planets पर ऐसा नहीं है कि सारे dwarf planet आपको क्यूपर बेल्ट में मिलेंगे some dwarf planets are found even in asteroid belt find out the name of the dwarf planet which is found inside the in the asteroid belt okay Rajni sir am I able to answer your query हाँ नहीं नहीं वो प्लैनेट नहीं है यदि प्लैनेट होता तो उसके आगे एडजेक्टिव नहीं लगाते यदि डॉर्फ लगा दिया है सो वी आर नॉट कॉलिंग इट एज अ प्लैनेट so we have a definite criteria for something to be called as a planet so it should meet the three criteria so you cannot called because उसमें planet लगा है तो वो planet हो जाएगा नहीं ऐसा नहीं होगा यूपीएससी ऐसी कंफ्यूजिंग चीजें आपसे पूछेगी भी नहीं है okay we'll see you then so thank you all